So we finished the inelastic demand slide, I believe, with it, the gasoline example. So some key points, which I think we might have already covered a lot of these. So as we saw, elasticity, like whether it's inelastic or inelastic, can change as you move up, down the demand curve. The rule of thumb is like as you move left, or as the price increases, it becomes more elastic. And then as you move the other way, it becomes more inelastic. And curves that are inelastic aren't inelastic at every point necessarily. There could be points when it changes to elastic, like we saw on the gasoline example, and vice versa. But so what that means is like here. So in this example, we saw that in this like lavender portion, in the higher price increases, demand was elastic, and then in the lower portion, the lower, relatively lower for gasoline prices, it was more inelastic. So and then it's important to see that like elasticity is a case by case calculation from one price change to the other, and just because gasoline is inelastic in most of the lower prices doesn't mean it can also be elastic in higher prices, or vice versa. Now, so it helps to draw visualize demand curves on the whiteboard itself, which we did. We calculated revenue at different points to determine or confirm that if it's inelastic, the rule of thumb is to increase your price. If it's elastic, the rule of thumb to increase revenue is lower the price. Okay, we looked at inelastic versus elastic demand curves as examples. What we did look at, which I don't know if is in the textbook, but just because it's important to see the extreme scenarios, is perfectly elastic examples and perfectly inelastic examples. So why don't I go here? So perfectly elastic on this tab, and if I defined perfectly elastic here, it would be so this means that actually the price is set by the market, and demand is constant at, demand doesn't affect the price. Okay. The price is set by the market, demand doesn't affect the price. And what you see here is that I just made something up, but a price of the price of this good is $85, and consumers can choose to buy as much as they want, but the price won't, in the short run, the price won't change, and in the long run, there might be some adjustments. But let me make this a smaller number because it's usually like expensive things aren't of this situation. If I made this like $2. Okay. And let me just adjust the scale. Max is there we go. Okay. So this is a bit of an extreme example, but it's important to understand the like boundaries of elasticity. So can we think of an example where the price is essentially set by the market, and consumers don't change their behavior based on price? And essentially, if it's, and what that means is if this was a good, and the consumer raised the price to $3, no one's going to buy it because they know the market price is $2. So this is something where there's no market power and no control of firms, where they've agreed, at least in the short run, that this is the price they'll pay. And any consumer producer that tries to get a higher price, consumers aren't gonna do that, they're just gonna pay the $2. So any ideas of what this kind of good could represent in the real world? Or how this would?
I cheated, I looked it up.
So what did you look up?
Commodities.
Well, it would, so the thing you wanna look at is. No, I mean, Bitcoin is determined by the different prices, right? Like, it's a, you buy and sell it, I mean, if the price goes up, some people sell it, and people buy it, right? Based on speculation. So the thing you wanna think of here is because in the elastic case, we thought of substitutes for the movie tickets, you wanna think here of like perfect substitutes. Okay, what I mean by that is, let's say, the best example is like going to a farmer's market, and let's say you go to a farmer's market and there's like one vendor that sells apples, red apples. There's another vendor that sells red apples. Right? You're at the farmer's market. You know that the price that's been set by consumers in farmer's markets is $2. And let's say that there's a vendor that sells the same apple, nothing different about it, for $2. And another vendor that sells it for $2.50. Exact same apple across the street. So is anybody gonna buy the $2.50 apple? No, right? Because they get the same apple for $2. So they have to be the exact same thing, which you can substitute. Otherwise, it doesn't really work out. But it's important to see that if things are if things are perfect substitutes, like apples at a farmer's market, or even like eggs at a farmer's market, if you're selling the same farm, the same egg, the only thing that determines who buys it is the price. Right? And the reason why they're not selling it for 50 cents is because the firms probably can't cover the costs. So if there's a set price of $2, you wouldn't want to charge anything but $2 because no one's going to buy it. They can buy the same exact thing for less. Right? So that's what the concept of a perfectly elastic demand curve. In this case, it's called a farmer's market apples. Okay, now in reality, most things don't fit this exactly because there's usually some different. If you go to the farmer's market, there's probably a little bit different apples, they come from a different farm, will taste a little bit different. But if they were the same exact thing, right, it's essentially like, if you go to a grocery store and they have the same product in different locations for different prices, there's no reason you would buy the more expensive one. Okay. Now the other extreme example, which is even a little bit trickier, is called perfectly inelastic. All right. In this case, let me define it as perfectly elastic. The quantity demanded does not change regardless of the price. Okay. So here is the way to think of it is, elastic, there's a bigger response in demand than price. Inelastic, there's a smaller response in demand than price. Perfectly elastic, there's 100% chance. Right? If you increase the price, everyone loses. And perfectly elastic, it doesn't matter what the price is, the quantity demanded is the same. So if there's 50 consumers, the price could be $40, $50, they're all gonna buy it because of the nature of this curve. Now, again, a bit of an extreme example, but can we think of an example where the demand for a good or service would be pretty much constant regardless of the price? So here we're looking at consumers don't respond to price. It's just the good is demanded at that quantity, depending on the number of consumers at any price.
I guess that's that.
Well, I mean, apples are sort of market.
So okay, so the demand doesn't change regardless of the price of them.
Correct. The price changes all different amounts. Quantity demanded doesn't change. It's zero. Percent change demand is zero. Yeah, it is.
Would that be something electronics?
It could be, but
Does that be like a certain product in electronics?
I'm thinking like toilet paper.
Toilet paper would definitely be inelastic, but I don't know that it would be perfectly. I mean, think of it this way: like if there's everybody buys toilet paper. If the price of TP went up to $1,000 a bag, I mean, some people aren't going to buy it. I'm not going to buy it. I'm just going to,
True.
take a shower and stuff like that. This would be something where you don't lose any consumer, right? This group of consumers needs this good or service. Water's a good example, but the price of water is it's a public good, so it's essentially set by the government. I mean, the reason why that's a good one because everyone needs water for water service, but because of regulations, you can't increase the price of water. Like you mean like water service to your home? Yeah. So there's restrictions that say like this, Golden State Water Company can only charge this amount or this. They have like a cap. Otherwise, the government would be like, news would be like, you guys are done. Like we're gonna get a new company. So that's a regulated market, even though it's an essential market. So we're getting close. Is that's something that you need regardless of the price, right? Yeah, that's what we're looking for is some kind of like insulin, some kind of medical service, some kind of like liver transplant where like if you needed to live, you needed to survive, those consumers are going to pay it. It might be like some might be the insurance company pays a significant portion, but regardless of the price of like insulin or heart surgery or like a liver transplant or stuff like that, it's going to get consumed by those consumers because they have to have it. So it's called this insulin. This very important medical procedures. So again, a bit of an extreme example, but it's important to see it. Okay, I can see why that is that amount. I mean, there might be some cap on insulin. There's less regulation on medical services because you don't really know what the true price is. Like if the price of insulin went to quadrupled, you can see some deal with insurance companies that are still going to pay it. But yeah, that's the thing is we want to see that these consumers. There is no substitute. Right? There's no substitute for insulin. There's no substitute for a heart transplant, things like that. Where like in this case, the gasoline, not a lot of substitutes, but you don't have to get gas. You can buy an electric car. You can buy. Okay. So Those are all the cases. All right, now, so this is a good slide because it illustrates things that would affect elasticity. And they seem, you think about them for a second, they make sense as you go along. And we'll look at some different types of elasticity and how that'll affect the curves after this. But first, know that so products that would work, we've already kind of discussed this, but products with more substitutes have a more elastic demand, like movie tickets. So the more the things you can substitute with something else more easily, or more elastic, because the price goes up, you just buy the other thing, right? Products with many complements have less elastic demand, and that I think there was a good example in your textbook about iPhones and all the like software and games and the apps that are only compatible with iPhones. And what that means is like, let's say you have a certain game or a certain app, and the app goes up in price or something. Because it's only compatible with the iPhone, you really have to use it only on the iPhone. So if there's complementary items, each one becomes a little more inelastic because it goes with something else. So if you needed to go with like a Microsoft Word, right? If Microsoft Word goes up in price, you've already got the operating system, you've already got the computer. It's a complement to the Windows, complement to your PC. You're probably still going to buy it. Whereas if it's like a standalone thing, like if it's just a an arcade game, the price goes up to $5. You don't have to play it, something like that. Or a round of golf, that goes up, you can do something else. But things that are complementary to each other make it more difficult for consumers to shop around because it goes with. Okay. Demand for brands is more elastic than industry demand, which makes sense because they could toilet paper again. So toilet paper, for toilet paper in general, it's pretty inelastic, right? Most consumers consume it. During COVID, there was a panic. Like it became one of the most prevalent things. Now, the demand for individual brands of CTP is less elastic. So something like there's Charmin, there's Scott, there's which I can think of. There's some other one. Costco brand, exactly. So if one of those individual brands raises their price, and the others don't, you just buy the other, right? So individual brands that have lots of competitors have to be careful, because the demand for the industry is different from the demand for. Actually, the same thing with like gasoline, because there's so many different gas stations. If one place, if there's two gas stations on the corner, and one of them raises the price like $3 more than the other, just go to the other, right? So you have to be careful of what your competitors are doing. There's I don't know if there is more, but in Huntington Beach, there's this corner that has two Arcos, and they're just like right next to it. It's really funny. There's an Arco here and an Arco here on the same exact street, and they both have the same exact price. So they've done something where like there's enough demand, like if one gets a little busier, they go to the other, but they probably like get on the phone, what's your price today? Because they don't want to lose customers to the other competitor. Okay. In the long run, demand becomes more elastic. Now that should also make sense based on like the gasoline example, because in the short run, the price goes up from $5 to $10. Most people buy it, right? But let's say that price stays at $10 per gallon for like 2 years. So what's going to happen is that a lot of consumers can make adjustments in that period, right? If you leave that price at $10 per gallon for a year, some people are going to buy electric cars. Some people are gonna take the bus, some people are gonna bike, some people are gonna call the bus and be like, I'm working from home, I can't. But there's gonna be some behavioral changes because they can make adjustments in the long run. Whereas if, you're driving to work, you have to get gas, you gotta be there in 30 minutes. You're paying that $10 because you gotta get there. So did you get more time to make adjustments? Any good of service pretty much becomes more elastic. And then the last one, as price increases, demand becomes more elastic. That's just a math thing, as we look at the graph, is we know that as you go up the demand curve, even for gasoline became more elastic. And so that's just the same can be true for demand. As price decreases, demand becomes more inelastic. So there's probably other things that can affect elasticity, but these are the 5 main points that were illustrated in your textbooks, which I think are good ones. Usually look at substitutes, complements, long run, industry demand. This one's not really a thing to consider. It's just a definition. Okay. Good on those? Yeah. Now we have this is the last slide, but I have a bunch of things I want to do on this one. So there's other types of elasticities. Income elasticity, which is how demand changes when income changes. Cross price elasticity, which is how a substitute or similar good changes price. What happens to demand for that good? And then advertising, which we'll get to later, but it's just when advertising goes up a certain percent, what's the effect on demand? That one's like no one. That's the mathematical question. No one really knows that, but it's something that if you could tell some company that advertising elasticity, they like you're the CEO. We're keeping it going. That's a difficult one to do. Cross price, we'll do an example, but cross price is how the price of how the quantity of good X changes in response to the price of a good Y, a related good. Yeah. Okay, so let's define these two. We'll define substitutes and complements, normal goods and inferior goods, and then we can do some demand curve shifting. Assuming my Excel is operates. Okay, so why don't we let's see. Okay. Okay. I'll define a few things first, and then we'll go from there. So let's define substitutes. And probably say like the consumer is indifferent between consuming good X and good Y. And then by definition, it needs a substitute. So if the consumer is indifferent between consuming good X and Y, we define those as substitutes. So the example from before was like movie tickets. Okay, so that would be like good X. And what's the substitute for movie tickets? Working. Methods, exactly. That's good as well. Okay. So, we'll look at in a minute if the price of Netflix, not directly comparable because it's like a monthly price, but still, if the monthly price of Netflix goes up, that should increase or have an effect on the demand for movie tickets. All right, and then complements. Would be good X and good Y must be consumed. Yeah. All right. So the example we had just a second ago was like iPhones, X, and then iPhone apps because you can't use the app other than iPhone. Right? Okay. Now, what about, I think this was briefly defined in the textbook, but there's a concept of normal goods. And there's a concept of inferior goods. The normal goods are quantity demanded increases if income increases, which makes sense. So most things would be like would be classified as this. So what's a normal good? Like you get household income goes up, you buy more of it. Close, yeah. Close in general, you buy more clothes.
My wife said
Yeah. Yeah, mine is, even if it doesn't go up. It's maybe that's a bad example. Okay, then the other one is a little trickier. Inferior goods. Quantity demanded decreases if income increases and vice versa. Or quantity demanded. Demanded decreases. So here you get more income, consumers buy less of it, or they get less income to buy more of it. It's the opposite. What is something like this? Yeah, that's a good one. So we'll call it like poor quality goods. Right? It's like microwave only or something. And then the reason why is because there's another, I mean, you can have better quality rice with more income, and so as your income goes down, you can substitute foodstuffs that aren't as preferable, but are more economical and vice versa. But if anyone has a high quality rice maker, I'll tell you, it makes a difference. Microwave rice is not as good as white rice that you let in the thing for like an hour. It really makes a difference. Okay, now that we define those, we need to define the types of elasticity that we need to illustrate, which are these two. Income elasticity and cross price elasticity. So substitutes, complements, normal goods, inferior goods. Let's do cross price elasticity. Okay. Cross price elasticity is equal to the percent change. Make sure I do these and the quantity of good X divided by the percent change in the price of good Y. Okay? The percent change in the quantity of good X divided by the percent change in the price of good Y. And so with this definition, we'd be able to classify it as a substitute complement, right? So, let's see. So basically, first one was substitute. So substitutes would have a cross price elasticity that is, so let's see. If this changes more than that, that would mean that the cross price elasticity is bigger than one, right? Because the percent change in quantity demand of X is bigger than the percent change in the price of good Y, right? So that means cross price elasticity is greater than one in absolute values. Okay. And then complements, you would think that, or actually, I'm sorry, that this will only mean, so it would only be like a negative positive. So essentially, if they're complements, if they're substitutes, I'm sorry, if this goes down, this goes up because it's a complement, right? So substitutes have a cross price elasticity that is positive, right? And then complements would have a cross price elasticity that is negative, right? Because if you consume them together and the price of iPhone apps goes up, then the demand for iPhones will go down a bit because you have to pay a little bit more for the apps. So it's and this is before we do the absolute value, but just knowing the correlation. Like, we know that if the price of good Y goes up and the demand for good X goes up, they're complements. It's a positive relationship. If the price of good Y goes up and the demand for good X goes up, they're complements. It's a negative. They're complements negative relationship. I think I got that right. So we haven't classified anything in terms of elasticity yet, but just knowing the sign of it would tell you this goes up, this goes up, there's substitutes. This goes up, this goes up, then they complement. Right? Makes sense? Okay. And then the other category, the elasticity, the income elasticity. Equals the percent change in quantity demanded of good X divided by the percent change in income. Okay, so if income changes by 10%, how much does quantity demanded change? And you can see that we can classify these normal goods and period goods similarly because if the income elasticity is positive, bigger than one, like a positive relationship, then the good is a normal good. And then if equivalency is negative, the good is an inferior good. Okay. Which is just the way we define it here. If income goes up, demand goes up, right? This metric has to be positive. If income goes up and demand goes down, the metric has to be negative. So just knowing the sign of these two elasticities will tell you if they're substitutes or complements or normal goods or inferior goods. Okay, and we'll look at, I'll do some graphical examples. Any questions on these thus far? Good. Okay, so we need to illustrate, I guess, graphically what an increase or decrease in demand would look like. Because thus far we've just gone up and down the demand curve and the elasticities. But we can do an example of, some, I guess complements and substitutes are kind of the same scenario, because we're looking at how good the price of good Y affects good X in different ways. And the same with normal goods and inferior goods. So why don't we just think of a hypothetical example and see what would happen to the demand curve if something else changes. Okay, so let's see if I can take this example in and I'm just going to take this original demand curve for let's do which one was our moving digits one? Yeah. This was our demand for moving digits, I think. So why don't we start with this example and let's define movie tickets and Netflix. This we're gonna have to call Netflix subscriptions because you don't pay a lot. Movie tickets and Netflix subscriptions are substitutes, right? Okay. So the way we gotta define, let's say that good X equals movie tickets. Okay. And then good Y equals Netflix subscriptions. Okay. So then what would happen? Let's say that the price of Netflix subscriptions increased, right? So that's good Y. Or I guess it's like the price of good Y. Okay. So then the question is, what happened to the demand curve for movie, which is good. Okay. So we got our demand curve here of movie tickets. We've defined movie tickets and Netflix's substitutes. Good X movie tickets utilize Netflix subscriptions, and we know that the price of Netflix subscriptions increases. Price is what? So the question is, what happens to the demand curve from movie tickets? That's the question. So if we know all this stuff, Netflix gets more expensive, what should happen to the demand curve for movie tickets? It should go up. And by going up, that means that at every price, there's a little bit more demand, right? So instead of this scenario, you have something like, let me put this over here to illustrate. Actually, I'm gonna put this over here. And then we can put the graphs next to it. So, the original quantity and price with these. Okay. And if the demand for movie tickets goes up, that just means that, let me call this Q star for the new plan. That just means that at every price, there's a little bit more demand, right? So maybe let's just add 100 for each original. So instead of zero, well, I'll leave it as zero just to make it simple, but let's add 100. So basically the demand curve would increase or shift to the right by 100. So it equals this plus 100. Right? And we can add 100 to all of those. All right. And then if I were to graph this new curve, okay. We could see that at the original prices, demand, it's kind of hard to see on it. Well, what I want to illustrate is that this new curve will kind of be shifted out like this, and hard to see in this scenario, but if I could show it. So kind of like that, like the demand curve would shift out to the right, and show that at each, this is, the draw this on the board, but at each price, the demand would be a little bit higher, and an increase in demand, in this case, movie tickets, is just the demand curve shifting to the right, like out from the axis, right? So the increase in demand going from like here to here. So it's the same, shape of the curve, same everything else. The only thing that changed is because of the change in movie ticket, Netflix prices, that there's a little bit higher demand for movie tickets. So this demand curve shifts out like that because of the other change, right? So our new demand curve would be kind of shifted out like this. And then this is the curve, it just doesn't, without showing it like this, you can't really tell it. But so our demand curve goes like out like this. Right?
The Q is, what's Q star?
Q star is the new demand quantity for movie ticket prices. after the increase in price for Netflix. Yeah, maybe I should. So Q star equals the new or increased demand for movie tickets. After the price of Netflix increases. Okay.
And then the market is the graph star and DB.
Yeah, exactly. I grabbed Q star and P. I was trying to get them on the same graph, but it didn't work. And I know there's a way to do this. I want to add. Um, these. So there's some way to get a second series on here, but I'm not.
So that would be like you original you already on there.
I want to, well, the original Q and P is already on there, but I want to put the new Q and P. So at each price, the demand will be a little bit higher. So instead of being 10, it's 110, and so it would just be kind of like this. It would be right next to it, but right now I'm not able to figure that out. We'll just leave it. That should not be the height. Okay. Well, we get the idea that the new demand curve. This is demand or new demand for DBA. Okay, and new demand you see is just about like that. Right, so the original prices, nothing changed in the price, the demand is a little bit higher. Okay, so let's look at another example of the income change. Maybe we'll do a decrease in demand because it'll be okay. So why don't we go to this one, the gasoline one, and do a shift around that one. So we did a cross price elasticity example with the movie tickets on Netflix. And why don't we do an income elasticity with the gas? Let's do an example of income elasticity. All right, so you gotta define these things. Let's say that let's say that gasoline is a normal good. Okay. And let's say that this is the demand curve for gasoline. So if gasoline is normal good, that means that consumers get more income, they buy more of it, and vice versa, or income goes down, they buy less of it. Okay? So let's then say that income decreases. Okay, so if income decreases, what happens to the demand for gasoline? Okay, so this is demand for gasoline. It's a normal good. And then we know that income decreases, and the question is, what happens to demand for gasoline? Sorry, income decreases. So what would happen to this demand curve if the consumers overall get like a drop in income? Yeah, normal good. Yeah, it should go down. So we know the definition of normal good is that with more income, consumers buy more of it, and with less income, they buy less of it. So in this case, this is normal good, and that means there's a positive correlation with income and demand, and so that would shift the demand curve down to the left. The demand for gasoline would decrease or shift to the left. Okay. All right. And the way to illustrate that is at the prices we showed here, right? We would show a smaller quantity demanded at each of the given prices. The prices don't change, and the demand curve would kind of shift in like this. So if I were to take these original prices and quantities, okay. Timer. All right, and then we make a Q star. So Q star would be the new demand for gasoline after income went down. So we know that going down means that there's going to be a little bit less demand at each price. So let's just like subtract one from all, or something like that. Or subtract two. So it's equals this minus two. Okay. So at $95 per gallon, instead of 2.5 demand, it's now 0.5. And then so on. At each price, it's a little bit lower, right? Such that when you did the graph, okay, it would be like shifted this way a little bit. Okay, so demand going down goes this way, the demand going up goes this way. So you essentially have a graph that goes from instead of 48, instead of 50, it goes to 48. So it'll just be like this. So I'm trying to get a visual for you, but if that demand curve shifted in, it would be just in this way a little bit. Right? So demand went down, meaning that at each price, because of the income change, the demand for gasoline is a little bit lower. Right? I'll call Q star equals the demand for gasoline after income decrease. All right, and this is the demand code. Decreased. demand for gas. Okay. So the idea is that we looked at all we spent a lot of time on the price elasticity, but there's other elasticities you can look at as well if you're a business or just interested. And two of the main ones are cross price and income elasticity. So cross price is the percent change in the quantity of X divided by the percent change in the price of Y. So you're looking at the substitutes or complements. And you're looking at how your good would change in response to the price of the related good, right? Whether it's a substitute or complement. And then income elasticity, you're looking at how your good changes, how the quantity demand of good X changes in response to a percent change in X, right? So, like the manufacturers of like poor quality rice or spam or like some kind of low income food would know that if income goes down, like we're in a recession, it's COVID, that they might want to try to sell more of that because overall income has gone down and the demand for that might go up and so on. Whether if we're in like a boom, there might be a higher demand for like restaurant quality stuff like that. Right? And then knowing these ones would know if you're Coke and Pepsi or something like that, knowing how your competitors' price change and vice versa would affect your demand. And the complements thing has a lot to do with those the tech things, the apps, things that you consume together, all the components of the car and stuff like that. So, all right. I think I covered what I wanted to cover today. Any questions on what we did? I'll post this spreadsheet, and you're welcome to take a look on it to see what we did graphically and not graphically. But I think we covered all the main concepts that I wanted to in this chapter. No homework assignments yet. But know that the other ones do so. So, all right. We're almost done. All right. Was any closing questions or was that? We almost did 3 hours. Is that not too much? What? Okay. Perfect. Okay. All right. So next time we'll jump into chapter 7, 8, whatever I think is all there. But today we just covered chapter 6. And I'll post that Excel sheet. But let me know if you have any questions. And I think we'll wrap up here for today and meet back in this classroom next week at 8:30. So thanks everyone.